Good morning, students. Today we are going to see the topic multimodal generative systems, CLIP, DALL-E and vision language model from the course Generative AI and the Agentic system. Let us start with the ice-breaking question. Can artificial intelligence understand images like humans? To answer this, let us compare the human thinking with the AI thinking. When it comes to AI thinking, it is completely narrow because it has limited logical analysis, and this analysis would happen through the data-driven approach. Also, it's completely task-specific methods. But when it comes to human thinking, it's too flexible, and though it is emotional, it is highly creative and intelligent, and it is more on self-awareness. So here the focus is how the language plus vision working together. So vision models, it works on the videos and images. When it comes to multimodal AI, it extracts the information from the text, not only the text, from the images and videos. So here the objective of the session is to understand the CLIP, Contrastive Language-Image Pre-training, that is what it is called as CLIP, and DALL-E and the vision language models, how it is working. So when we apply this design thinking to this multimodal AI, we can explore the various applications, and it has long future scope. Let's see that how this multimodal AI works. It has 6 steps. The first step, it has to collect the data. It starts collecting data from various sources, and certain features have been removed in the second process. Then it would combine with the different modalities like images, videos, text, etc. Then it creates the training model data, then followed by the generation with the inference, benchmarks and points. And finally, it will be recommending, and that recommended things can further be expanded or enhanced. So here the problem statement and or persona is like to bridge the meaning between the text and the images. Let's take a student or a product designer. They have the pain points of doing the ideation process, which gets very much slow, and they have a very limited design skills. Like for example, if you take a unimodal approach, like write a description of a horse, if it is a prompt, the generative AI model will be decoding a horse is a magnificent animal that belongs to the equidae family, if it says. When it comes to multimodal, it describes the picture of the horse, then it provides a picture of a horse. Then it will write a song about a horse. With these 3 instructions, 2, 3, 4, the prompt gets integrated, and then finally it gets decoded. So the results will be like a image with the audio with the text, this is horse. So this is the difference. This is explained in the diagram of unimodal and multimodal. So let us understand the user needs and expectations through the empathy process. Like we translate the ideas into visuals quickly. Like for that we have a method, the empathy mapping, like thinking, feeling, saying and do. If you see that the input image is given with the building of 3 people, and what color shirt is the referee wearing. So it's a play, it's a football game, it could be a football game or some other game. So here is the input question. The convolutional layers of CNN network, okay, neural networks, it extracts the features one by one, and the question is featurized with attention prediction, and it will find finally that colors of the shirt images through the attention weighting features, and finally it finds the relative importance of the image regions. So this is what the multimodal, how it works when it comes to the image analysis. So here the design thinking of defining the semantic gap between the language and vision is to align the representations. So here, how can AI match the text with the images? Let's see that. In left hand side, the object localization is one cat behind another. Okay, if it is zero shot segmentation, it's a striped cat. If it is zero shot with a visual question analysis, then what is the breed of these cats? So one shot learning with the instruction, it will be finding these striped cats are called tabby cats. So what is the breed of the cats in the image? So it will analyze the cat's image with the stripes. So here the visual language model, finally it is found, yes, one cat is behind the other in the image. So the cat in the back is facing the camera, while the cat in front of it is facing away from the camera. So thus the cats in the image appear to be domestic short hair cats. So this is the final output. That cat is in the image or tabby cats. Tabby cats are common domestic cat breed and are characterized by their distinctive coat pattern. So stripes on the body and a fringed tail. So this is the description we got through this vision language model of the particular image. So here the CLIP, as we know that it is expansion of contrastive language image pre-training, and it is used the dimension of matrix 2D matrix which takes the process of text encoder and followed by the image encoder. The intersection of text encoding and image encoding which makes the process of joint embeddings for the text and images, and which this is actually called as zero shot image understanding. So here the technical level, how it works, like in transformer, it takes that normalization and feeding forward method, and finally it has multi-head attention. When it comes to CNN, it has the multi-dimensional convolutional layers with 1 by 1 layer initially, then it is 3 by 3 dimensional layers. So that encoder, and finally it creates the contrastive laws aligns with the embedded images. So here the student activity is to match the clipping. So increase the cosine similarity of the correct pairs in the batch, or another side reduce the cosine similarity of n squared minus n incorrect pairings. So this pairing, it works in small groups. So whether it would be leading to succeed or fail, so the outcome of this image pairing will be the result of the visual language model. And let's take the DALL-E, the text to image generation. Here the image is being generated with the clip support, and if you take that, here is an example given, a corgi playing a flame throwing trumpet. So at the time of encoding, the image encoder, it makes the image of keeping the trumpet in the left side and the corgi dog in the right side. When after it is getting decoded, the corgi image is on the left side and the trumpet is on the right side. So here the in this example, how the image is being integrated with the text and the image. So another example of the text prompt, like fox, forest, autumn, misty, sunlight, 8K resolution and best quality. If it is the prompt, see the first output and in the second output. Second output is more AI generated image, and that is the outcome of the DALL-E. And which is more accurate, whether it is left side or right side, it is in the right side. That is the prompt engineering where it is completely utilized. So vision language models, short form, it is called a VLM. It has the input of prompt, how many buildings are visible in the image and what is their current condition. So with this, we apply multimodal GPT vision, Gemini, with all this. The textual description, if it is, it will produce a comprehensive understanding with the visual content. So here is that tools are used to BLIP, Flamingo or GPT-4 version, the captioning, reasoning, everything in the form of visual language model. So finally, when it comes to the applications, it is highly used in the healthcare, education, robotics. And the quick questions for the self-assessment: why CLIP is more important for DALL-E? Let's take students can take the role play of AI designer or a product owner, and you can create a discussion among yourself, and how the multimodal AI impact your domain. So this peer group discussion will help you to create assessment on that. Finally, the summary, here it is. We have visual language model, small language model and large language model, and how it will be helpful in the generation of images with reasoning. Thank you, students. Let us continue next class.